Good afternoon, everyone, and welcome to today's webinar, Automating the Mold Design Process, brought to you by Cimatron. Presenting for us this afternoon is Ralph Picklow, Vice President of Sales, and Dan Branch, Support Manager for Cimatron. Before we get started, I would like to mention a couple of presentation logistics. First off, this webinar is being recorded, and we will be sure to send you an email with details on how you can view the recording when it is available. Second, we welcome questions, as we will be conducting a Q&A session at the end. Questions can be submitted throughout the presentation by expanding your question box in the right-hand control panel. Simply type your question to an organizer from the drop-down selection. Note that only one control panel can be expanded at a time. If we don't get to your question due to time, we will follow up with you via email or phone following the session. With that, I would like to turn the floor over to Ralph to begin. Ralph?
Thanks, Lisa. Welcome, everybody, and thank you for taking the time out this afternoon. Before we get into the demonstration, a couple of quick facts about Cimatron. We're a worldwide company in over 40 countries, a leader in integrated CAD/CAM solutions for design and manufacturing for mold, tool, and die makers, as well as manufacturer of discrete parts. We're a public company with 28 years of experience and 40,000 installations worldwide. We have 300 plus employees worldwide as well. Interesting note on our mission statement, it is Cimatron's mission is to become the CAD/CAM software of choice for the tooling industry worldwide through continuous innovation, attention to customer needs, and superior technical support. That's our mission, and if we look at our target market out there, we're in all of the markets, transportation, consumer products, electronics, machine parts, medical, toys, packaging, aerospace, and more. Okay, Dan. In today's webinar, you'll learn how to significantly reduce time and effort of your mold design. You'll see how you can standardize and automate your design process, and how you can benefit from most advanced mold design functionality. With a lot of this functionality that we've added to the software, you'll see how we take the daily task of a mold designer and automate the process. Some of the highlights that we'll be going over, our process is totally flexible, it's automated. We can work with any type of data, which is a very strong point, whether it's IGES or SAT, STEP, any of the standard formats, along with the direct formats. We have some part analysis tools. You'll see Quick Split. You'll see how we can use standard and non-standard mold bases, runner, ejection, cooling design, and then adding mold components with the cutting object, which is very important. Also, we have an ECO manager, because we know everybody gets engineering changes halfway through the process of the design. And we'll also explain the full associativity from start to finish. So I'm going to turn it over to Dan Branch, and we'll take a look at the software.
Thanks, Ralph. Let me bring Cimatron up. Well, to talk about mold design, we need a plastic part. And like Ralph was saying, a CAD system for tooling needs to be able to import all kinds of 3D data. And in this case, we've imported a Parasolid file. The deadline requirements for tooling mean getting started right away. You cannot have anything holding you up, we know it, especially the built-in limitations of a CAD system. And Cimatron can immediately work on any data of any quality. This part does have a few problems common to imported data. Nothing too serious, just a couple of open points and edges. That would prevent this part from being deemed a perfect solid. But this is absolutely no concern at all, especially for mold design. one of the first things we need to do is split the part open, not stop and worry if it's closed. There are some other analysis tools we can quickly look at besides checking for gaps. For example, we can get an overall measurement that includes the flat projected area. This can help calculate the press size needed. These results here can be exported out to a nice report with a picture if you're in the quoting stage. And then for mold design, an important decision is draw direction and the draft on the part given that direction. And you can check this right away in Cimatron using a draft analysis tool. I've already oriented this part for draw direction. So the colors that we see on the screen here relate to that. Although there is a dialog that explains the colored ranges you can set. A red color would indicate an undercut given the direction we are looking. Now we can flip the arrow in any direction. And on the screen we can also call out angles that we may think would be a concern. Ideally, now would probably also be a good time to look at simulating the plastic flow in the part and maybe trying out some gate locations. This is an option inside of Cimatron, and it's just not something that we're going to look at in today's session. So I'm going to leave the part at this point. A mold design is just a big assembly of parts, and this screen is for starting a new project. It creates a standard assembly structure, puts it in a job folder. And the requirement today is going to be a 2-cavity mold. So I can choose from a set of standard layouts as a template. So the Cimatron environment will be familiar to most everyone. The tree on the left shows how the mold components will be divided up into some logical sub-assemblies. And the assembly called parting is active first, because that's where we're going to work on the part. This guide on the right is just for quick access to common functions. I want to make the point that there is no order to follow here. Cimatron lets you work how you expect to work on the design, not any strict rules of the system. For some jobs, a mold base might come first, or part and ejection, or whatever the need might be, that's the way you can go about it. We're going to start by loading the work part. Now, because this is a plastic mold, the system knows that scaling for shrinkage has to be applied. And it's going to offer it to me right here. We're going to accept that. And right now, that scaling is being applied. It's happening automatically as we import the part into the project. The 2-cavity template that we chose has provided 2 points on the screen to use. And that gives us a start on where the mold cavities are going to be. At that step, we can tilt the parts for draw direction, but again, I already have the part set to pull in Z. But by adjusting those layout points, the parts can be arranged in the mold in any fashion. For example, I want to rotate one of these parts around. And I also want to move the parts a little closer together. So moving those layout points moves the part. And later on, an adjustment here will move everything in the mold that's based on the part. Now, because this is really one part in 2 locations, we only need to work on one of them. So the other one we can hide away in the tree. And because this is for a plastic mold, we know we want to separate the part into a top and a bottom, a core and a cavity. The Cimatron way to do that is to work directly on the part data. We will determine the parting line, and then we're going to create some parting surfaces out from it. The parting function, called quick split, will do an automatic analysis on the part. The calculation going on here, again, this is looking at our part along our defined draw direction, and it puts any geometry that it's sure about into a top set or a bottom set. And then we can visually slide the model open to get a first look at what core and cavity will sort of be like. Anything that's left over in the middle here could be an undercut or a needed side action. What I'm going to do is assign these faces just using a mouse click into the lower set, and that's someplace that we can check on them a bit further with. The first check is again going to be the draft analysis. But because we use quick split first, now we're able to check in both pull directions at once. So anything now that's showing up in red is definitely a problem to be looked at. For example, these windows in the part. Now we can create a third pull direction here, like out to the side. Quick split has no limit at all to how many directions you can pull, but we don't really need to do that here because this area was kind of designed to slide by itself. So these faces really only need reassigning into the other set, into the top set, again with a mouse click. Again into the draft analysis, and a closer look does show a real problem. This red that we're seeing along this edge, along this front round, this is a common issue actually, where rounds meet drafted walls. And a mold design system has to have a solution for creating new parting lines and solving this. The solution in Cimatron is to split any face by a silhouette curve that looks down our draw direction. So this whole round now has been divided along its true parting line. Cimatron makes finding parting lines on complex surfaces something that's actually very easy to do. But then we do have to return to quick split and put these little pieces back in the appropriate set.
One other note on the split silhouette, which is a very nice command. The split silhouette, you can also enter in a value for 7 degrees, so it will split it from the horizontal up or down 7 degrees. You know, if you have to have grain or texture in the mold, you can automatically get that line, instead of at the silhouette, up 7 degrees.
We're going to make one last check here and use a dynamic section that lets us see into the part better. Because what we could see is one of those faces I sent to the bottom set was a true undercut. This red color is showing it pretty clearly. So this shelf here needs to be released from the mold by a lifter. And I'm going to choose to ignore this for now. Because again, we can work on the mold design in any order we want to. And that helps us really move ahead quickly. So these are the faces then that we've designated to be in the core and cavity. And now we're going to move to building the parting surfaces that radiate out from them. It might be easiest to visualize that if we hide one of these sets. So I'm going to use a handy tree that's made by Quick Split, where I have display control to turn these sets on and off. So let's look at some parting surface creation options. And the first one we're going to use is called external. It's really ideal for parting lines because it spreads out from the part edges, but it stays as flat as possible to the draw direction. So in the beginning here, I'm going to change some edges. And then I need to fix the vector direction. The arrow indicates draw. Now the distance I'm going to enter here is only really important in that it goes out past the eventual size of the cavity block or the plate that we're going to cut from. For our case, 4 inches is going to be enough. and you see the result. You see how it radiates out. It makes a nice, smooth parting face. Another type of surface is sweep. And sweep doesn't spread out. It just goes in a straight direction. But sometimes that's exactly what's needed, like on the end of our part here. Now, our part is symmetrical, which means we can take advantage of a mirror function and copy some parting surface over to the other side. A lot of plastic parts are like this, as you know, or even parts that are left hand and right hand. So mirror has to be a handy tool in the system. And another handy tool has to be strong ability to trim faces. When you're working with surfaces, either in the part itself or on the parting like this, the ability to quickly trim them anytime is a must. And this is something that Cimatron has always excelled at. So we trim those off to each other. If we look at this last area then, I'd like to fill in this gap with the smoothest surface possible also. And this time the surface type I'm choosing is a blend. A blend is a very powerful optional step that's going to bridge an area, but it also precisely follows a guide curve. So if we show the rest of the part again, what I'll do next is assign some status to the surfaces that we've made. What I'm informing the system that these are the parting lines. And it's also very nice to see how a copy of the parting faces will move along with the part. You can really kind of see what the cavities are going to look like at this point. So now, even though the parting on around the outside is defined, there are still many open areas in the middle of the part. Sometimes these internal shutoffs are easy to fill. Other times they can be quite complicated. So for the easy ones, Cimatron has a tool that just seals them off. What I'm going to do first is ask the system to identify all these simple internal loops. Now we saw how the external surface worked. So here we're going to use the internal surface command. It seals off any of the flat or the contoured areas that we ask it to do, really in one click. And this can be a huge time saver for parts that have a lot of internal islands. Now more difficult areas need something else. And Cimatron has a very smart extension function called close open faces that we want to look at next. And it works on open solid technology. So what I'm doing here is first I'm unstitching the faces I want to work on from the rest of the part. The rest of the part being the blue area that currently is hidden. So the close open gaps function, it works by selecting an internal loop. Then all of the boundary faces are extended out to meet each other. And this function is doing amazing things that we've seen in shutoff areas that used to take a lot of time to extend and design. Now, like before, we want to assign these internal surfaces as parting, so we can visualize a copy in both halves of the mold. And that really leaves only 2 windows in the part that I've left undefined here. But I'm going to leave those open for now to save time, but also to show how Cimatron can keep moving ahead in the design process without worrying about gaps or undefined areas like this. And I can come back to the parting area anytime for changes or adjustments, but really the next move is to work on the mold itself by creating the cavity blocks. So I'm going to use an export function. I'm going to ask that the new part be called core, and that it be located in the movable side assembly of our project. Now here's where the knowledge I assigned in the quick split function really pays off. So you see how it knows all of the data that's in the lower set that needs to go out to the core block. So here's the new part core with the part surfaces in it, but it's not the end, of course. We still need to define the core block size, and that can happen now. What I'll do here is I'll use the sketch environment to design a centered box that will then extend into our workpiece. Now this solid then, it represents the workpiece block. It's going to surround the part. This will be the stock that we're going to trim off by those parting surfaces that we just made. So another export utility. And again, we're going to see how that work that we did in Quick Split pays off again. The system knows any parting faces that belong to the side we're working on. And you see here how they're lighting up as kind of a visual check that things are as we expect them to be. And then lastly, an arrow which shows the part of the stock that's being cut away for our finished core block. There probably isn't a simpler way to build a mold cavity from a part. It's the parting faces that cut the solid block, just the surfaces we built. The part itself, whether it's good data or bad data or with unfinished shutoff like we have here, it just comes along as is. The whole core block can be described as kind of a hybrid solid model. We can do anything to it. For example, a few rounds on the back edge are no problem. Cimatron does all kinds of operations using the speed of solid modeling, but without wasting time with a restrictive requirement for perfect geometry. I think it's now time to get a mold base involved in the design process. Cimatron ships with over 20 catalogs from all over the world, and adding a mold base is a catalog operation. Here we're going to use a PCS standard configuration. On screen, what we'll see is a preview of the mold as we make decisions to the size. And to determine the X and the Y, if we'd like to, what we can do is ask the system to choose the best fit for us based on a minimum stock we want to keep around the cavity blocks. The plate thicknesses, they're standard but adjustable as well. So as mold-based parts are created, we're going to see them entering into the assembly tree over here on the left. The system knows which plates, which components belong in which area of the mold design. And the entire mold assembly being created right now is associative, of course, so it's editable at any time.
I think one of the things to note also is you picked a standard from a standard mold base from PCS. You can also go ahead and pick that mold base, and then you can go non-standard and type in any of your sizes, whether it's length, width, or an odd size plate. You can go ahead and put that in as well too.
Now what we're going to do is we'll be looking at some very specific functions in Cimatron that are just for mold design. But first, what I'd have to do is add a few more parts here. And I'm going to start by placing our second core block into the design. What this will be is an associative copy of the first block. In other words, the same part in two locations, so that any change to the one will affect the other as well. And again, we're using those original layout points. And what that does is it keeps the cavities connected for easy adjustment later on. And we're also going to create a runner block for this side of the mold. It's very easy to pick up contours or reference other parts while working in Cimatron. And any reference between parts is associative. So which means that the whole design is going to be able to update and adapt as the changes come along. Now also a pocket in the B plate is needed. That's the last thing I need to do here. And again, we can use the references from neighboring components in the design. What this will do is create a pocket for us that stays related to the size of the core blocks. So, okay. Now, one of those specific mold functions that I mentioned was for cold runner designs. Runners are created by driving a profile shape along a sketched path. And our design today really doesn't have the need for a long runner, but I can show one to show how the function works. So the dialog that is showing now, it offers a choice of runner sizes. And because of the curved parting line here, I think we're going to choose trapezoid shapes. The numbers are adjustable, of course, to whatever's needed. Now the runner that gets modeled will be used as a cutting object solid. So it's going to intersect with any of the other mold components that the runner path crossed over. So here's a look at a typical result. Next on the list to discuss are inserts. Most molds have inserts of some sort. The catalogs that we mentioned, they have core pins and other standard parts, but sometimes inserts are custom to one area. And Cimatron has developed a fast new tool for breaking these out as new parts in the assembly. For example, on our core, this tall area here in the center is an ideal spot for a replaceable insert. And I'll only need to define that area, and that's something a quick sketch can take care of. Now you recall that the core block is an open model. Big holes in it. And we simply don't worry about gaps unless there's a good reason to. Well, here I'm going to use a solid technique for creating the insert. So beforehand, I am going to request to stitch together one area of the core block. This is an example of Cimatron letting our design needs dictate the course of action. I only need to worry about the geometry that's right in my current working area. So an insert function, in the insert function I need to pick the block and the new shape to cut from. And I'm also going to specify in the tree where the new insert part goes, and then just set the depth of the cut. And this will break out our new piece. Insert 1 is here. You see all that's left in the core block is a pocket. The insert itself is all new part in the assembly. An insert like this probably needs a screw to hold it in place, as does the core block for that matter. And that's going to bring me back to standard catalog parts one more time. You can save a lot of time with a well-built catalog library. But even better, our catalog assemblies of many parts at once. The Add Mold Component Guide is a shortcut to thousands of catalog parts within Cimatron. At the moment, we are looking at the DME catalog. Amongst all the standard things that we can use here is a DME unilifter assembly. Because we really can't forget that undercut area that's still left in the core. Now this type of adding parts we'll call add on a face. And all we need to do is pick the anchoring face for the lifter unit. And then we want to make sure that we have a reference point from the relevant geometry in the cavity. So once the parts are on screen, that's when we can deal with adjustments to the size and the positioning a little bit. This unit needs to be turned around. And then we can also add a dimension. In a catalog group like this, the important sizes in the individual parts, they're called out as leading dimensions. And because they're purchase parts, the leading dimension dialog only allows you to choose from the sizes that are actually offered. Now, also in this add operation, I want to note that we're adding with cut. Okay. What it means is that these parts already know what holes and what pockets they need to install in the surrounding plates. So I'm going to section the job a little bit to show the cut results. You see pockets in the ejector plate, holes for the screws. All of this comes out of the catalog. In Cimatron, adding parts also add the pockets. It saves a lot of time for the user. Now the cuts have gone so far as to make the lifter pocket in the core block as well. And I really have to be careful here not to get too much of a good thing. Because I need some of that geometry in order to create the face on the lifter. What I'll do then is step backwards one feature in the history tree of the part. See, I can manipulate the timing of the cut by using the tree. So that lets me do operations in any order that works the easiest for me. Now, because of Cimatron's ability to work so well on the open solid sheets, here in the lifter, all I really need to do is bring in a bit of geometry that will give me the required shape I want. Okay, and the next choice will be a cut function. And cut understands how to trim off the lifter blank, and it can even delete the surfaces that we use for the cut after it's done with them. Remove cutting object. So that creates just the lifter we need. The only thing that remains is to go back to the core block and bring the history there back up to the current level. Well, lifters help eject, but most molds have some sort of ejection system with pins. And here again, Cimatron has a special set of functions that really help to speed up the process. What we're going to do is go back to the catalogs one more time, but this time place some ejector pins. Now there are an awful lot of sizes for ejector pins. It's a big table, and what we can do is sort the table to make things a little easier to see. Also, we'll ask that the system calculate length. What it can do is measure the distance from the ejector plate up to the core, and you'll know exactly the shortest pin you can choose out of the catalog. Now this time, while I'm adding parts on face, I'm going to ask for the snap grid to be on. A lot of users like this. Well, for ejectors or other components that can be placed at nominal numbers. And we'll drop a few in there. Now, for our purposes here, note that what we're going to do is leave the cut without cutting the holes. Because for ejector pins, there is a special type of hole available. This is done by ejector pocket. What ejector pocket can do is look at every pin. And it's going to see where it's going to break through the core block at, and then back figure of the reamed hole size for a constant fit length. And there are other drill options there too. You can, well, rather than have a set fit length, you could choose to have a set clearance length, or no clearance drill at all in the core blocks. Whatever really the shop standard is.
So this here is basically looking at the high point or the low point or the midpoint of the intersection of the pin to the surfaces, and then coming back, I think you put in a 1/2 inch. So you're going to have a 1/2 inch of fit on your pin here. Doing some pretty intense calculation there.
Another dynamic section to see what Ralph's describing. Cimatron also has developed a function called ejector trim. Now, ejector trim saves an incredible amount of time in mold design because in this one function, you're going to ask it to act on all of the pins, and it trims the tops off right at the top of the core block surfaces. The system knows the structure of the mold assembly. It understands where ejector pins have to stop at. Okay, designing cooling channels is another mold task that Cimatron helps to automate. I'd like to show a simple example of that now. So to create an entire circuit of cooling lines, what I have to do is start with a sketched path. So in this case, I'm going to add a basic loop through the mold in a top view. And in this case, too, we'll leave off the dimensions. That's just so we can get to see the end result quicker. So the preview on the screen is the cooling circuit. All we really need to do is edit the size of the hole we want. And also what I'd like to do is let's take a look at the visual analysis here. What this will do is make a visual check for the cooling line collision. So what we're seeing on the screen now is actually an offset value that's being applied to the cooling channels. And any interference that's found at this level, it's going to show up as a bright red mark. So at 375, we're actually touching one of the pins. But really, this looks okay. So we're going to accept this whole circuit design. And it instantly does the cuts and the holes and all the components that are affected. I'm going to finish the discussion of cooling by once again going into the catalog area. All kinds of components like baffles and O-rings can be found in here. Cimatron has a very special ability for adding round parts like these. What we're able to do is add into a cone face, and it's very useful for tool design. The catalog component will position itself right at the end of the water lines, all over the place. This kind of intelligence, again, it really saves time over manually positioning all the parts that a mold will need to have. Well, as we've been designing and all this has been going on, Cimatron has been tracking all the work we've done. All of the new parts are found in a master bill of materials. And this is something that you can customize and set up. You can export it to drafting or maybe something more like Excel if you prefer. And while the mold design here isn't finished, the ordering of parts can begin. As can NC or electrode design or any of the other things that Cimatron can help you with. Those are other specialties that we don't have time to talk about in this session. At this point in the design, sadly, what usually happens right about now is that your customer decides to change the part. Engineering changes. They're a fact of life in the tooling industry. And so I'm going to end today by looking at how you can quickly incorporate changes to your part into the ongoing mold design. Now, changes have to be tracked. And so Cimatron can help by providing this handy little internal notepad. It's called ECO Document. It's up to you how much detail you want to add here. You can add a description. Every EC is going to have a name. You can link to the new file. There's a click for adding pictures that will help describe. I have to find the right folder, though. Okay. So when you've decided that that's enough in the ECO document, you can accept. Now, Cimatron actually provides two ways of implementing the changes. And that's why in the guide here, you're seeing two choices. One for updating the work file, or one for updating the cores and cavities directly. And we feel it's important to offer both choices. A Cimatron user can assess how vast a change really is and how much of the existing mold design is going to be affected. And that's really what's going to dictate which method you will use. I'm going to choose here to update my work part. So you will see that the system knows what data to be looked at. There we are. Because we've entered it in the ECO document. The new part now is being overlaid into the original part. Now this new data doesn't have the scaling for the shrink rate on it because it came right from your customer. But Cimatron even takes care of that for you. The system knows the shrink rate and it adds it. And the end result of this analysis is being shown on the screen here with a red and a blue display. The blue faces are the new ones, and they're going to be added into the project. The red faces are the old ones, and they're going to be removed from the project. And we end with the new data sitting in place of the old data. That will need to be distributed down farther into the cores and cavities. So we end up using, again, one of the first tools we looked at, which was QuickSplit. We can edit the existing pull directions and have the system find and sort the new changed surfaces for us. Now, any real change to a part is bound to affect parting as well. This one is relatively easy, but still, we have an internal shutoff that's going to need redoing. And to solve it, I'm going to use the same functions I did before. And then update my core and cavity, and it will receive the new data. And I'm going to keep working on that, but I've really shown all the methods I was here today to show. So what I want to do is turn the session back over to Ralph and Lisa and see if you have any questions for us.
Yeah, thanks, Dan. Couple of comments to review what Dan has shown today. We showed about 50% of what the mold design product can do. We're trying to get through this and show as much functionality as possible. A couple of things to note. Basically, again, we don't have to use a perfect model. Dan went through this whole thing with doing the whole mold design, and he hasn't decided how he's going to do those 2 open windows on the one side. The flexibility of moving in the direction and how you want to work is a strong point with our software. The other thing to note, too, is there's no set order on how you go through the mold design. If you want to bring in your parts, lay out your parts, bring in a mold base at that time, you can do that. The same thing with the ejection and cooling. If you want to put the cooling in first and then put the ejection in, or if you want to put the ejection in and then the cooling, it's up to you. It's however you want to work. The nice thing about it is, you have to get it done, and we're giving you the tools to get it done. So, again, the flexibility and the automating of the process is to, your standards. One other note on it, too, as well, is the catalog components with the cutting objects. All of our catalog items have cutting objects, so it's going to fill in the place, the pocket or the clearance for the component you're adding. So a lot of flexibility, a lot of stuff we went through real quickly. So I think, Dan, you've gone through the engineering change?
It's going to calculate for a minute, Ralph.
Okay. Do we want to, let's go to the PowerPoint. Again, here's some of the highlights again. The flexible automated, design tools, working with any data. Some of the part analysis tools, as you can see, was set up for mold making, where you get the 2D projected area, the quick split, the standard and non-standard mold bases, runner ejection and cooling design, mold components, again, with the cutting objects, the ECO manager, everybody gets engineering changes. Again, Dan talked about full associativity through the whole process. He goes back and changes the layout, and somebody says the mold base is too big, we got to make it smaller. He can close those the layout up a little bit, and everything's going to update. And same thing with the drafting. We didn't get into any of the drafting or the electrodes or the NC. It's all full associativity and updates downstream. So a lot to the product and a lot to show in a short amount of time. We're going to go ahead and open it up for questions. Again, on screen you'll see how to submit some questions. Dan, do you have anything to add? Yeah, do you have anything to add before we get into the questions? Dan?
Do I? No, sorry. I don't.
Okay. All right. I'll read some of the questions that we have. Is it possible to do the same kind of thing but with a mirror part? Dan, I'll let you answer that one.
Yeah, absolutely. Well, mirror, we showed a little bit of it, and you saw that when I mirrored the surface, it was a copy. Mirror is something that we're working on right now because it's at a basic level of functionality. What mirror will do is always copy. It doesn't move. So if you've got an existing tool design and you want an entire mirror of it, it's going to take you a little bit because it will certainly pick the parts, mirror them over, and you'll have that copy. If it's 2 parts in one mold, then it's really not any different than what I was showing. Instead of the 1 part twice, you'd add the left on one side and the right on the other and work on them in that fashion. If they're true mirrors of each other, you don't even have to work on one. Just work on the other, work on the left, for example, and then when you're done, mirror it over and create the right.
Okay, thanks, Dan. Another question, too, will this work on family parts? Again, as Dan said, you load one part and then you load another part.
Yeah, that load work step, Ralph, as you know, we can have as many layout points as we want, and we can use load work as many times as we want. We have lots of customers doing family molds with Cimatron.
Another question here is, I've noticed that ejector pins come in without the option of adding a D-lock. Is there a way to add this automatically?
Absolutely, there is. Obviously, the pins I designed in there would have to be keyed, and I just pulled a straight pin out of the catalog. We do have a catalog with a with kind of a flat on the side, but what we ran into is a lot of shops do it differently. So, I mean, if you want the flat-sided catalog, I can give it. If you have a special key or something, what that falls into is creating your own catalog parts. So with a special cut. It's really simple to do, and I have a webinar that's recorded on the support site for showing just how to do something like that.
Another question that's coming up is, what is the overall file size of the project? Any tips for when performance suffers on large projects?
A few tips. First of all, the part size that we were dealing with here was about 10 meg, and when all is said and done, the assembly is maybe 30 meg. I mean, it really was a demo, so we could get through a lot of steps quickly. We have customers doing molds that are absolutely gigantic in automotive industries and others, and the best thing they can do for yourself are A, have a good PC with a ton of RAM in it, B, we have a 64-bit version of Cimatron now, and the 64-bit version of the product will access that RAM that you've purchased, whereas the 32-bit, of course, has a limitation from Microsoft built in. That's really helping because big jobs are heavy, and there's just no two ways around it. But the Cimatron is now available in 64-bit, and we can really use almost all the RAM you're willing to purchase.
And I think the other thing to note too is, as you're working on the mold and you activate, you know, the ejector system or just a component, you're just loading that component into the, you know, into RAM. So you're not using the whole, you're not loading the whole mold every time as you activate, you know, different components and stuff like that. So with the way we break it up in the assembly with sub-assemblies and then your different parts, you don't have everything loaded right up into RAM. So another question is, how long did the part change take to calculate?
Oh, well, I saw a peek of it. If we want to go back, what I think I need to do is I need to reassign some parting attributes because I was trying to update parting here and I see it's not looking so good. Regeneration is a fact of life in an associative CAD system. What I probably should do instead of parting is at least try to do this update. But again, I may have to go into quick split. The question is, how long is it going to take? And it takes anywhere from 2 minutes to, I don't know, 10 minutes. I alluded to 2 options in the ECO, and really this is something that we'll be talking about as the version 10 gets out into the populace. The second method updates not by going into the parting file, but going directly to cores and cavities. It's a couple steps, but it avoids regeneration, period. And I think this is what a lot of people are going to be using, especially on the complicated molds, the ones that are done more than this. I mean, you assign them right into the cavities. It knows which ones to delete and which ones to add. Regeneration is 0. You know, some may look at it as, well, you're skirting the associativity aspect of the system. But that's why there's a choice. I mean, associativity is great when it's quick. When it's not quick, people aren't real fond of it. So Cimatron offers a choice.
Another question is, are all the components you added today standard items with the product, or are they add-ons that you have to purchase?
Everything that we've seen, well, that's your question, Ralph, isn't it?
Yeah. All of those catalogs are standard, with the mold design. They're constantly being updated all the time, and they're all included. All of the catalog components and all of the cutting objects are part of the catalog component. Let's see, some of the other questions about templates and title blocks for the drafting. We'll address those through support. Let's see. Can Cimatron work with an STL file? Yeah, we can do a mold design in an STL file. You're able to bring in the STL file, and you're able to bring in all of the design all solids and surfaces around that. We don't have many tools for repairing the STL.
Right.
But yeah, if you have a scan model that you have to reproduce a mold, we can bring that scan in. We do have a reverse engineering product that you can take and create your own STL or create surfaces. That's another product if you get into scanning parts. Couple more questions. Let's see. The mirrored parts.
Here's one I'll take real quick, Ralph. Do you have a webinar or tutorial available on making templates and title blocks? The answer to that is I think so. There is help and tutorials in the system right up here at the top of the screen if you use the help menu. The support staff works hard and makes a webinar every month on different things. Before the webinar ends, I'd like to mention our number, which is 877-596-9700. If it's something like creating a title block, I can help you do that in a couple minutes on the phone. It's not something that I have to make a tutorial for. So give us a call. That's what we're here for. Go ahead, Ralph.
There's another question about conformal cooling. If I understand that correctly, that's where the cooling channel follows the part. I don't think we have any automated tools for that. A couple of things that we can do is we can take and section the part and then offset the section down, let's say a ½ inch, and put a drive, a pipe command through that. That will enable you to put a cooling channel that way. Nothing automatic for that. And I think that's about it for the questions.
There's one question about the 64-bit version I see. If you have a question on that, again, I'd like you to call the tech support. It is available. We don't have a DVD that we've printed. I've got many customers running it, and I'd be happy to hook you up with it.
One other question is somebody's asking that they got pulled away and missed part of the webinar. It will be recorded, or it is recorded, and it will be available. And if you've signed up and registered, we will send an announcement that the video is available. So I think we're all set.
I agree.
No more questions. I'd like to thank everybody for taking time this afternoon to watch the webinar. Again, if you have any further questions or anything like that, feel free to contact us. We're on the web, CimatronTech.com. And again, thank you everybody for taking your time.